So the first thing you do is go to the data entry documentation. And we're going to follow this. So the first thing you'll need is an account to get into BETYdb, and if you don't have some of the options that I show you, you will need to ask me and I can give you elevated permission. Right now we're going to go look at the TerraRef instance of BETYdb, which looks similar, but you can tell that it's different. And then I'm already logged in here. We're also going to be using Mendeley to track and annotate citations in Google Docs to prepare and transform the data. GitHub to track data that need to be checked and or corrected. So we'll go here to finding and preparing published data. So we've already got a data set that I want to use as an example. It's some data collected on a population of sorghum plants that we used in the TerraRef program, and we want to add this. So the same varieties of sorghum were planted in South Carolina back in 2014 and 13 and 14, and we want to upload that into our database so that we can analyze that alongside the data that we collected in Arizona. So the first thing we're going to do is we're going to use Mendeley, and we've got a group. We use the groups. There's the biggest value of using Mendeley is the ability to add and annotate papers in a collaborative way. So I'll open up Mendeley. I've already got the paper out. We have a folder called TerraRef that has publications from our project as well as this new one that we want to enter data for. So one of the key parts about this process is that there's a separation of steps between the scientist who can identify the data that needs to go into the database, and a technician who can enter the data into the database. And this is not meant to be dismissive, but it's to recognize the fact that it's a complex problem, and typically when you're trying to coerce information that doesn't have a standardized or even complete set of metadata available, it's all written out as prose in a document, a published document. It's very hard to figure out a lot of the context of what the experimental design was, where it was done, what's meant, and how that fits into a more rigorous or more constrained and clearly defined scope of what's allowed in the database. Mm-hmm. So for example, different studies may have different ideas of what a control is. You might have different ideas of what the treatments are, but our approach is typically to identify all of the different components of the experimental design and quantify them, like the fertilization rate, the dates of planting, the actual varieties of plants that were planted, and characterize those specifically. So the first step is for the scientist to annotate a paper, and so which I've already started doing. And annotating a paper, you go through and you identify where the experiment was done, other factors that we're going to enter into the database, such as what the planting density was. Right here it says what the experimental design was. Underneath this comment error it says 2, so I say this is the experimental design, randomized complete block with 2 replicates per variety. This is some of the managements that we're going to put in. Most important typically is nitrogen fertilizer. Also indicate that it was irrigated, although there aren't quantities of that. And
Are you making these annotations on Mendeley? Sorry.
yes, this is all within Mendeley. So I've done all these annotations within Mendeley.
Is that something you can share or something you don't want to share?
No, I can share and I can make it public. Yeah, that's it.
Okay.
Yeah, that is the idea and the advantage.
Yeah, I'm not that familiar. I have this paper uploaded into Mendeley, but I'm not sure what else, where to go from there.
Okay. Yeah, so I can go here and can I share this, edit settings, remove folder? This is where I need to create a group, so sorghum. Because in the past we've done it with switchgrass, Cetaria, etc. So do it by species, create the group. It will be public, and I can invite Emily there.
Oh, so I'll be able to see your annotations.
Yeah.
Oh, okay, cool.
So now you've been invited to this group, and I will move the paper over there. Okay. So that's the scope of annotation, and primarily what we're interested in is the phenotypes that were collected, and those were made available with the paper in a file called file S2, the supplementary file S2, which I have in my downloads folder, and I can upload to Google Docs in order to prepare that. But before we get around to uploading the CSV file, the first thing that we need to do is to begin the process of entering data into the database. So entering the metadata. So this is the metadata. This is everything before we actually upload the trait and yield data. So we're going to go through and we'll use this bulk upload to add trait and yield data from that CSV file. So the first step is to go to citations, and then we want to add a new citation.
Okay, yeah, got it.
Okay, so the new citation, typically we'll just use the first name of the author here. So this isn't actually a bibliographic record. This is to uniquely identify the paper within the database, and in order to link it to a bibliographic record, we use a DOI. So this was done in, information is here, so 2016. Let's copy this information over. And then the DOI is here. Easiest way to do the URL is just to update it with the DOI, and now we have this citation. We'll call it Breton 2016. Okay, now we don't have any sites associated with this citation. I don't think we have anything from South Carolina at all. So I'm going to add a new site, and I'll come down here, and this is where we get to start digging out the metadata. This site is called the Clemson University PD Research and Education Center. It is in, so we don't, not all of these are required, but we'll say that it's in Florence, South Carolina, United States. Now for the latitude and longitude, they don't provide this here, and I also want to note that this is different than the way that we identify individual sites for the TerraRef project, when we have plot level geospatial information, we can define those interactively in the SQL database using the geospatial column and make a rectangles where the plots are. But in this case, we just have a field site, and this is very typical, especially when doing meta-analyses. All we know is that it was done at this site, so we will just go in. We could find it on here, go down to Florence, see if we can find out where the PD Recreation Center is. It's not that easy to find, so the next thing we can do is go to here. I'll just paste that in and go to Maps. And there it is. And I can right click here. I can look at the satellite just to see what happens. So it's likely that this happened, somewhere in here.
Mhm.
But I will assume, we don't know, so we'll enter it with an appropriate level of geospatial precision. So there should be a way that I can ask, Google, what's here? And it's going to tell me here is the coordinates. So go back here. We can also get a sense of what the level of precision is. I need to on how big this is. So I need to pause. So what I'm going to do here, so if I just look at what this location is, and I come over here and I say, well, what's at like the northern end of this place? I think what's here, so we can get another set of numbers. And we can see that that given how close we know that we are to the PD Research and Education Center, there's no reason to keep more than 3 digits of precision here. So I am going to 289 to 299. So really closer to 2 digits, but 2 digits should be sufficient. But I'll keep 3, but no more than 3 in order not to give the wrong impression about how exactly where this happened. So this is the location with the appropriate precision, and the appropriate precision goes also for when we upload the data later. A lot of times when we transform data, we'll come up with arbitrary position that is not meaningful. Okay, here we can go to the latitude. I was close. And the longitude 79,737. Okay. We don't have information about the soil. If we were very interested, which I think might be useful for this project, we could go into the USDA database or find somewhere else what the soil classes are. And a lot of ecology papers don't tell you in here what the soil classes are, and they'll also tell you what the climate is, all these other parameters, mean annual precipitation, etc. is pretty common, but that's not the focus here. This is sometimes there will be additional information about the site you can put into notes, but there's not in this paper. So we're going to mark this as this is not in a greenhouse, and we'll create that site. Okay, so the next step, we've added a citation, we've added a site. This tells you more details about all those fields. This tells you about the level of accuracy, how to put in bounding boxes if you want, instead of, which requires not the user interface, but access to the underlying database. Okay, so next we're going to do adding treatments and managements. So this is a case where a statistician might look at this, or the biologist designing the study might say, well, our treatments are the different genotypes, for example. In other cases, a treatment might be 2 different years or 2 different fields, but we're just going to call all of this a control treatment. Really, what we can assume is that these plants were managed according to best practices in agronomy for the region, and so that's what we will consider a control. And then within that control treatment, we will use other information in the database to identify the different year that these studies were conducted in and the different genotypes that were planted, which is really what, from the statistical point of view, what you want to know is the genotypes, and then there's additional information about the environment contained in the location and the year. But we're just going to create one treatment that is a control treatment. So we're going to go to I need this to create the elevation when setting a geometry. So now I'm going to ask, what is the elevation of Florence, South Carolina? It's 183.38 feet, but we need to know what the meters above sea level is. 138 feet to meter in meters is 42. Elevation in meters is 42. Create. Okay, so now we have a cite and a citation, and now we need to go on. So you can see that's the guide. We have the next thing to enter is treatments. So we want to use an existing treatment. No, we're going to create a new treatment. So the name of this treatment is just going to be, I'll call it. So one of the keys here is that you want to figure out, you want to identify, you want somebody who's reading the paper to be able to identify which treatment you're referring to. So that's how you would name it. If it's, for example, a fertilization treatment, you're not going to have to identify the amount of fertilization that was done here in the treatment, because each treatment will have managements that quantify things like the planting date and the fertilization rate and any other managements that were conducted. So we're just going to call this BAP phenotyping trial. So Clemson BAP phenotyping trials. And the definition is, I won't define it here. That's not necessary. Phenotyping, I think that the name captures what it is. We need to have at least one control per study, and we're going to create that. So now that we have all of that uploaded, we can enter managements. Now at this point, managements are optional, but they're useful. In particular, I want to indicate what the rates of nitrogen fertilization, what the planting dates and what the rates of fertilization are. I'm actually going to have 2 treatments, both of them being controls. I'm going to have one per year. So I'll call this one, there's one in 2013. And then I'll have another one that is 2014. I'll go back here so I can call it the same thing, except change the name. And I'll say true, create. We've got 2 treatments. So I'll create a management for this treatment. This management is going to be the planting date, which we have right here.
Okay.
But there are a few managements here. So one, we have the planting density, we have the planting date, and I'm going to call it, so for 2013, so 2013 and May 16th, the management type was planting, and we can say the level of planting is going to have this density, which is 9,000. It's unfortunate that I can't see this with that note thing there. Move that over here. There we go. That's nice. Okay. 96,000 plants per hectare. So how many plants is that per meter squared? Meter squared per hectare. So you have 10,000. So that would be 10 to the 5th. 96. And 9.6 plants per meter squared. That looks like a reasonable number for a field trial. So now we enter here, 9.6 plants per meter squared. Oh, the units are already embedded in there, but I'll say it again, plants per meter squared. And I'll just say 76 centimeter rows at a planting density. I'm just going to copy and paste that. This is a nice place to put the notes, just so. Okay. So now we've got the notes. Create. And then, so we have this management associated with that. Now we create a new management for that treatment, and that's going to be 2013 and May 2014. Wait, no. This is 2014, May 6. Okay, so we have another planting. Okay, the other thing is a fertilization rate of 225 kilograms per hectare. And so this is going to be 30 days after May 16th. May 16th plus 30 days is
June 15th.
June 15th. Okay. So and then fertilizer nitrogen. What's the rate? The rate is at 125 kilograms per hectare. Okay, 125. So type of fertilizer not specified. Okay, and then we'll add, and so 30 days after May 6th would be June 5th of 2014. Okay, and each of these were harvested on a different day. Basically, either down here it says each plot was harvested at physiological maturity, or October 1st, whichever came later. So we won't add a harvest date. The biomass measurements, it will be implied that the harvest date was the date. So now we've got all the metadata set up, with the exception of cultivars. So in this case, we've got a lot of cultivars in our data set, and we have relatively few, well, a lot of them will probably already be in the database. Some of them won't be. We will address that when we get to it. There's one way of adding new cultivars as you go, which is to come in here and add new cultivars. But if we were to do that for more than 10 of them, then we would get tired of going through each of these pages. So for all of these pages, whenever there's, well, I'll just say roughly 10 or more entries, it's worthwhile to go to a spreadsheet. So there's also ways in which you can add for this. We can add new traits, and we can go through, and this would be something we do. For example, if I'm pulling data, in some cases there might be, you know, 1 or 2 data points per paper. So here, if the data weren't available, there might be limited utility to this, but because there's so much other data on sorghum, but we would just take, for example, the average and the standard deviation and the sample size and call this a value for height and dry weight. So if I wanted to know generally what these values are for sorghum, then I wouldn't enter the cultivars. I would just enter the species, and I would enter these values, and then I might just go through this and enter, you know, this handful. We've got about 10 values. I would enter these manually, but we have, fortunately, these authors have provided us a nice spreadsheet of raw data. And so if we, just to show you where I got this, okay, so we'll go there, and now I can open this in a browser, and I can demonstrate that they have in fact given you the supplemental data down here, and we're going to be looking at file S2, the phenotypic data used in the analysis. Download that. It's already been downloaded. But what I really want to do is I want to upload this to Drive. This is new. And then file upload. So we've got this Excel file here. I'll just go ahead and upload that. And then I will open it with Google Sheets. So one of the tricky things here is to get all of the data into the right units. That's why we have this Google Sheet. So I'm just going to call this the raw data, and then I'm going to create another one, which is going to be for upload. Okay, so, and then I'm just going to copy this and paste it there. Dry tons per acre. We have dry weight, kilograms, dry tons per acre. So this is another common thing that we need to do, which is to convert from tons per acre to whatever the standard one is in BETYdb, the standard value for biomass. So if we go here, so let's see, so biomass, what do we have? Above ground dry biomass, kilograms per hectare. So that's what we want to be entering into this database. So we want to convert from tons per acre to kilograms per hectare. So I just put that up here to remind myself. And the variable name is above ground dry biomass. Above ground dry biomass, common unit conversion. So US tons per hectare to megagrams per hectare. So that's what we often use for yield, is megagrams per hectare. Do we have tons per hectare? Oh, and then megagrams per hectare to kilograms per hectare is times 1,000. So first we're going to say times 2.24 times 1,000. So we're going to say that times 2.24 times 1,000. And we get that many kilograms per hectare. Okay. And where there's value, we will empty that out. And then where there's an NA. Oh, didn't want to do that. I'm just going to put that in bold so that you can, so that we know that we're going to open that, we're going to enter that. And it would be nice, I could do all of this in R. That would be the ideal way to pull this in and do it all in R. But in reality, this is how it's often done. The reason I say that is because I just violated one of the rules of spreadsheets, which is not to use formatting to indicate meaning. But I'll be okay with that for now. Let's insert one. Okay, so the harvest date, so I'm going to call this date, and so the harvest date is days after, that's days after planting, and so this is what I need to do is I need to add 126 to the planting date. So in 2014, we recall that the planting date was May 6, 2014. Well, let's see. We'll call this planting date. I'm not going to enter this either into the database. We just want to have it in here. And I'm going to format this as a date. This is the standard way of doing it. Year, 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 month, month, day, day. And I'm going to days. Okay, so maybe that's all I need to do. Plus 126. Yes, that's nice.
Oh, nice.
Okay, and again, this one, since it's going to be used to upload the data in the standard format, so format number like that, fill down.
It's adding 126 to all of them.
It should be B4 plus D4. And now we can fill this down. So I'm just highlighting it, and then I hit Control D to fill it down. Okay, so now we've got our date. So this is our harvest date. But that's when all the other measurements were made. So what are all the other values that we want to put in there? So now we can go over here. Let's just look at, well, if we look at the variables table, you can see what else is in there. So ADF, that's a percentage. This is all percentages. That's great. I think that we're going to find the same, and the name is ADF, so we're just going to rename this to ADF, and then you can do this for each of these. Neutral detergent fiber. It's not clear why we have two of these in here. Oh, digestible fraction of nutrient detergent fiber. So these are actually two different measurements. NDF is here. NFC. So here we might go and find out what NFC is, because we might have another variable name for it. So, but if I look at lignin, so it's not the index leaf lignin content measured using NIR. Let's see how this was measured. So here we can check on the values. NFC, cumulative measure of non-structural carbohydrates. So we're not going to take that if we don't have the data, if we don't have other data to compare it with. So we're looking at BAP. What was the other one? So lignin, is it in here? What did they use for lignin? So this isn't just leaf lignin. So we could either create a new data said there was leaf lignin. I mean, there was whole plant lignin, but we're not going to do that. So we just won't upload these data. It's important to prioritize and not just take all of the data that's there, because otherwise you'll end up with a lot of long tail data, and there's diminishing returns on getting things that are not the same. But things that are of use are things like stalk height. So let's see how stalk height was, or how height was defined in here, so we know what to compare to. So when it says height measurements from the base of the stalk to the apex of the panicle. Okay, so that's basically our canopy height. So we're taking at physiological maturity, base of the stalk to the apex of the panicle. So height of the top of the inflorescence panicle height. Canopy height from there. Top of the general canopy of the plant, discounting any exceptional plants. Plant height, maximum vertical height from the base of the plant. So this is more general than height to the top of the panicle. Okay, so we're going to call this plant height. And we want that in centimeters, which this is in centimeters. The only thing preventing us from uploading this as a CSV through the bulk upload now is getting the making sure that we have all of these cultivars in the database, which we probably are missing a few. So that will have to be saved for another. So I'm going to rename this cultivar. And I'm going to delete these two things right here, delete these rows. So this one's going to be downloaded. So the bulk upload is going to ignore anything that we don't actually have data for. I'm going to just see what will happen if we try to upload this. There's a lot of steps to the bulk upload that will prevent us from uploading data that doesn't make sense, that doesn't have the necessary information. There's a lot of documentation on how to format the CSV file, and I'm going to open the bulk upload in a new tab. I'm going to choose my file and see what happens if let me validate this. So if you have a cultivar column, you must have a species column as well. So it gives you a lot of information, helpful information like this. So okay, so I would fill this down, try again, and then there's going to be a lot of back and forth about this as we find errors. I suspect we're going to have to remove those underscores